Thanks very much for the opportunity to talk about the CHERISH project today. I'd like to begin with the three questions that CHERISH tries to address. The first is, what are the main impacts of climate change along the coast of Ireland and Wales? The second is, how do we measure these? And the third one, probably the critical and important one, is what do we do about this? CHERISH is a 6-year project. It's funded by the EU Ireland Wales programme, and it involves 4 partner organisations. There's the Royal Commission on Ancient and Historical Monuments of Wales, which Louise is also sharing this talk. They're the lead partners in the project. There's Aberystwyth University, our other Welsh partners, and in Ireland there's the Discovery Programme and the Geological Survey of Ireland. And the 4 of us then combine to look at the impact of climate change along our respective coastlines. Now, coming to that first question of what are the main impacts of climate change, in Ireland and Wales, predicted by 2050, are a number of changes to our current climates. We expect to see summer average temperatures increase by about 1.3 degrees centigrade. We expect changes to our precipitation. Winter precipitation is going to increase by about 5%. We're expecting hotter, drier summers alongside that. And sea levels, due to the melting of ice caps and the thermal expansion of water, are expected to rise across both countries, looking at about a 20 centimetre rise. Storms are also expected to change. Maybe the frequency, magnitude and duration of storms will alter by 2050 and going forward. And the combination of all these elements are going to lead to changes on our coastline. And the main ones are probably going to be changes to wave impact arising from storms, storm surges that get pushed up onto our coastlines, combined with maybe high magnitude rainfall events that occur. And so we're likely to see changes to processes occurring on our coast. That's the erosion and the accretion of sediments along them, and also probably changes to coastal flooding. Now, this will impact right the way along our coastlines. It will impact the cultural heritage, which is of focus of the CHERISH project, but will also obviously impact any other feature or structure along the side. And it's certainly becoming a big issue for government. In Ireland, it's predicted there's going to be about 70,000 homes impacted by coastal flooding by 2050. And then in Wales, it could be looking at up to 240,000. So big changes likely to the people living there, but big changes to the cultural heritage that exists. And the CHERISH project is then looking at ways that we can measure and record these changes, and looking at then how we can use that understanding to affect the management of cultural sites of significance. How do we do this? This comes down to the second main question posed at the start, is how do we monitor and how do we record change at the coastlines? It's a very changing environment. You have the marine realm, you have the terrestrial realm, you have your processes that are occurring at each side that then combine and impact and affect the coastline and then sites within that coastline. And for this reason, we are applying an integrated methodology to studying the sites of importance. And it's one that draws on the experience of all 4 different project partners, their backgrounds, their expertise, to monitor and understand our coastline. And there are probably 3 key elements that kind of like inform the CHERISH project's approach to it. The first is to establish baseline data, and that's both for the geomorphology along the coastline and the shape of the coastline itself, but also then the archaeology that's on there. So it's using techniques like geophysics and kind of like coring to look at that archaeology. When we've established that baseline, we're then looking to perhaps monitor change, both long-term change that has already occurred, but even over the length of the CHERISH project itself, to try and see, can we record any change that's occurring, and then from that to understand the processes that are happening. And that's the third critical point, is understanding what's happening to these points to then inform management decisions. And the images that you see in front of you gives a bit of an overview of the suite of techniques and a lot of digital techniques that we're applying to understand and to try and come up with a holistic understanding of the processes that are occurring maybe on a regional scale that are then impacting the local sites of interest. What I'll do is I'll start with the big image and the kind of like, that incorporates most of what we're doing. And I'll start from the offshore area that we're using kind of marine surveying techniques that the Geological Survey applies in its marine mapping program to map the seabed. We're combining that with the diving experience of our archaeological colleagues in the Discovery program to understand wrecks. And then coming on shore, we're combining that with skills of all organisations, including the Royal Commission, Discovery Programme, Geological Survey of like terrestrial laser scanning. We have the sort of like archaeological surveying or kind of geomorphology of Aberystwyth University on rope courses. On shore, we've got paleo-environmental work that Aberystwyth University are doing, looking at the long-term history of it. There's geophysics studies that are going on both sides of the water, and using those terrestrial techniques, we're also then combining them with survey techniques from the air. So we have LiDAR surveys, there are aerial photographs, UAV and drone surveys, and even we've trialed using satellite images and using satellite data, and bringing all of these different techniques, all these different technologies that bring different elements to studying this very, very dynamic region to try and then understand what's going on, and then to try and perhaps going forward manage what's going on. I'll be in the first part of this talk looking at the techniques that are going on, and then Louise, colleague, will then start looking at how we've applied these to one site over in Wales. So when I talk about data collection, we collected on a variety of scales, right from the tens of kilometers down to almost the meter to millimeter scale. And so I have a few examples here. There's satellite imagery that we've investigated and used. And so you're talking about tens of kilometers of data there that we're assessing. Coming down to kind of LiDAR surveys that we've had commissioned and are continuing to commission of islands on a kilometer scale data acquisition there. Down to UAV surveys is the kind of like the main image there at the back, where we've been able to, over the course of a number of days, kind of get up to probably about 8 to 10 kilometers stretch of coastline with our UAVs, which is probably about the maximum amount there. And then right down to individual sites. So using scanning total station to actively monitor just one eroding cliff face itself, and from that to try and see on a very local, small scale what is occurring there. And again, what we are trying to do, and what we're trying is integrating all of these technologies. So looking right from the small scale down to the large scale of these changing coastlines. We're also trying to integrate these technologies. So each of them has their own advantages and disadvantages that can either to do with its method of acquisition or the scale over which it's able to acquire that data, or the temporal scale that you're able to return and acquire it. And it ranges from kind of like take our LiDAR data, where we would try to get about 16 points per meter squared over a kilometer scale area, to our UAV photogrammetry techniques, which we would deploy over sort of like a kilometer, probably 1 up to about 12 kilometer scale, where we'd expect maybe about 1,000 points per meter squared, right the way down to our scanning total station, where we could get upwards of 160,000 points per meter squared. So again, different techniques applied in different areas to then try and record first off that baseline data to try and assess what our coastline and what our sites of interest, our cultural sites of interest, what they look like now, from which to then assess change. And once we've applied our techniques or our integrated approach, and maybe combining our UAVs, which could be quite good at taking surface shots and recording the sort of like the elevation of the kind of like the flat areas or gently sloping areas, compared to something like a scanning total station, which could be very good on a vertical surface or an area of quite complex geometry to accurately pinpoint and record the shape of that to maybe detect change over the sort of like scale of years up to longer beyond the end of the CHERISH project. What we're doing then with all this data, once we have acquired it, once we've processed it and cleaned it, is we're looking to build 3D models of our areas, of our regions of interest. And these are some examples from Ireland where we've flown our UAVs. There's Kilmichael Point at that top left one, where there's a promontory fort nearby, and there's an old Coast Guards centre there. So we've used our UAV to get that regional picture, and then the image on the right there is an integration of our UAV with scanning total station, which could be used to record perhaps in more detail the exact sort of like situation of that old boathouse at the moment, and then where the individual stones themselves are now lying on the beach, from which to record any future change. We've also deployed them in a number of range of other different counties. The examples on the bottom there, just from Dalkey Island, a recent flight that we flew there just in last September. Once we have our models, we're also looking to try and create a larger picture as possible of what's going on. We have to remember that the sites that CHERISH is looking at are coastal, and it means that you're not just being impacted by, say, your terrestrial processes, your terrestrial flooding and rainfall, or your marine processes, being storm action, being underwater currents and the general flow of water around these sites. It's a combination of the two of them. And one thing that we are accomplishing in CHERISH is to try and integrate data from both the marine side and the terrestrial side into a seamless onshore-offshore map, which then formed the basis of our kind of like further investigations to understand change. And so this is an example in Puffin Island over in Wales, where in 2018, the survey vessel from the Geological Survey went out. We mapped a number of locations, a number of shipwrecks, but also the sea floor around Puffin Island, and to build up as big a picture and to try and push the bathymetry as far onshore as possible. And what we've done here is we then combined that data with the LiDAR data that was commissioned and acquired by the Royal Commission on Ancient Historical Monuments of Wales, to then create this seamless onshore-offshore map. And what we're going to do with this then is to use it to understand the hydrodynamic processes that are going on and how they impact the cultural sites on the island. So what we're doing is we're applying a range of techniques, and we are trying to combine those to understand, first of all, what the current coastal structure looks like, and then from that we hope to understand change. And what I'd like to do now is I'll pass over to my colleague Louise. Louise will carry on and will give a specific example of how this is occurring over in Wales.
Thanks, Kieran. Our case study site is Dinas Dintley in Gwynedd, North Wales. Here, a late prehistoric coastal hill fort is constructed on a hill of glacial moraine overlooking the surrounding low-lying coastal plain. Roman finds, together with a prominence in medieval Welsh literature and folklore, indicates the site has a long history, one which continued into the 20th century when it was incorporated into a Victorian golf course, and then during the Second World War when pillboxes were constructed into the lower slopes of the hill as part of the defence system for the protection of the nearby RAF Llandorog, now Carnarvon Airport. Dinas Dintley is owned by the National Trust, is a scheduled monument for its archaeological importance, as well as a site of special scientific interest for its geological significance. It is accessible to the public and the Wales Coast Path runs across it. It is also a monument at risk, suffering extensive erosion, particularly along its western seaward side, as this aerial image shows. Here, gone are the hill fort's double bank and ditch defences, and we now look directly into the interior of the fort. Using maps and 25cm LiDAR data, we've analysed erosion at the site since 1900. In this time, upwards of 50 metres of the western side of the monument has been lost, and based on these rates of erosion, not even taking into account climate change predictions, we estimate that the whole monument will be lost over the next 2 to 5 centuries. Erosion here is happening incrementally, but also through major localised collapses, as seen in the two UAV images, which shows the before and after of the substantial collapse in the cliff face at the end of January 2019. This clearly exposed a section of the hill forts in a ditch. Over the past 4 years, CHERISH monitoring at the site has provided a detailed analysis of erosion pressures. Many of these are depicted on this CHERISH illustration, which describes future climate change and the predicted outcome of this on the marine and coastal environment. At Dinas Dintley, the most significant pressures are from extreme weather, particularly storms with strong winds and rain, which from a seaward direction are eroding the softer sand sediments in the cliff face. Prolonged periods of rain, an outcome of warmer, wetter winters, are also a trigger, as this causes the ground within the monument to become saturated, at which point water emerges from the cliff face at the interface between the soft and hard sediments, leading to slumping and collapse. In the future, rising sea levels, the result of warmer global mean temperatures, will pose an increasing risk. Sea level in North Wales is predicted to rise 19 centimetres by 2050 and 34 centimetres by 2080. At all our CHERISH study sites, we're undertaking survey and data collection as outlined by Kieran earlier, to provide an accurate baseline data set from which future change can be accurately monitored. During the lifespan of CHERISH, we are also undertaking repeat survey, at least once, to quantify change, and Kieran will be looking at this aspect in more detail shortly. At Dinas Dintley, we're integrating technologies for our monitoring and have used 3 techniques to gather data. For the actively eroding cliff face, an area of just over 300 metres, we've undertaken laser scanning to provide a data set at the highest resolution. This is a relatively time-consuming survey process and requires good, still weather, not the easiest thing to guarantee in the coastal zone. Data was gathered over a 3-day period from 46 scan stations, georeferenced with GPS and processed to a mean error of 4 millimetres. For the whole monument, including an area around it and the intertidal zone, we've undertaken UAV survey using a DJI Phantom 4 Advanced, and it gathered 3 sets of monitoring data in 2018, 19 and 20. Compared to laser scanning, this is relatively rapid process in the field, with overlapping images, mainly vertical with some obliques, gathered over a 3 to 4 hour period, roughly 1,500 images taken at an altitude of around 70 metres. And here I must make note of the licensing, planning and permissions needed to undertake UAV survey, which is even more important here as this site lies within the active flight area of the nearby Carnarvon Airport. The survey is georeferenced using ground control points surveyed in GPS, and once processed using structure from motion software Agisoft Metashape, the resulting digital elevation model has a resolution of 3.5 centimetres. Our last UAV monitoring survey was undertaken in September 2020 to coincide with the spring tides. Here, we linked with CHERISH partner, the Geological Survey Island, who undertook marine survey at high tide. The lower left image shows the raw multi-beam data gathered as viewed on board the RV Kiri. On the land, the CHERISH team from the Royal Commission undertook the UAV survey at low tide. Once processed, we're hoping that this will provide the overlap needed to close the white ribbon zone and thus produce a seamless offshore-onshore model of the study area. As a final note, I should also add that for all our baseline and monitoring surveys, we produce reports fully outlining the methodologies and processing statistics. These, along with the data, will be made freely available. Imagery captured and data produced from the UAV surveys has enabled us to produce a range of products for the more general public consumption. Video taken from the UAV was used to produce a film, available in both Welsh and English, and here's a short clip. This has been a great hit, viewed thousands of times on YouTube and Facebook and prompted some great discussion. The resulting digital elevation model was also 3D printed at A1 size. This is a great showcase and has been used at face-to-face events such as talks, walks and school visits, and will be a feature in future exhibitions. For the virtual audience, the data has also been used to create a Sketchfab model, and this is something we've done at a number of our study sites, all of which can be accessed via the CHERISH website. Once loaded, you can pan around and zoom in and out of the model. Added information points or hotspots also provide the user with a virtual guided tour, exploring a range of themes covering the hill fort's history and archaeology, its complex geology, and the erosion processes affecting it. It's also possible to inspect the model, remove the render to look at the underlying wireframe and surface model. So far, I've outlined the data gathering side of our work at Dinas Dintlay for the purpose of impact monitoring, but for a site at threat, it's essential that we increase our understanding of the monument before more is lost. We've therefore undertaken a variety of investigations, non-invasive and invasive, both within the hill fort and the surrounding landscape as shown in these images. This has been undertaken by the CHERISH team, but also through work we have commissioned, which thus far totals nearly €90,000. An example of non-invasive work has included 3 different forms of geophysical survey. Initially, magnetometry to identify remains within and around the hill fort, including the field to the south. Based on the results, we then commissioned targeted resistivity in the hope of gaining more information concerning a mound in the interior of the hill fort, and ground-penetrating radar to help more clearly understand the depths of deposits and archaeology within the interior. Main highlights from these surveys include a busy hill fort interior with evidence of roundhouses, roads and divisions, a newly identified ditch which may indicate a northern annex to the hill fort, the course of a sinuous approach from the south leading through the southeastern entrance, and extensive archaeology in the field to the south of the hill fort, including field systems and medieval and post-medieval settlement. Invasive work has included 2 excavations. The first by the CHERISH team targeting exposed archaeology in the cliff face, particularly that of the inner ditch section shown earlier. A good head for heights and a safety expert is essential for this type of work, though it is costly and difficult, and the archaeological survival varied. Thus, for known archaeological sites, a much better methodology is a targeted programme of excavation rather than a last resort excavation at the cliff face. Having said that, recording the exposure of the inner ditch in the cliff face was a much quicker method than through a trench excavation. Once cleaned, we used the UAV and survey control to produce a photogrammetric image of this complex section, which was subsequently drawn up in AutoCAD. Our second excavation was a community one, run for us by the Gwynedd Archaeological Trust. Over 2 weeks, a series of 8 trenches were excavated, both within the hill fort and in the field to the south, all targeting anomalies from the geophysical survey. Over 50 volunteers took part, the majority from the local area, and an open day attracted over 400 visitors. Here and at other sites, we've worked hard to involve and engage the local community, who have provided us with a wealth of information, a great interest and willingness to help. At this point, I would like to pay tribute to CHERISH volunteer David Ingham, who very sadly recently passed away. David was our eyes on the ground at Dinas Dintley, a local resident who helped monitor the site for us, particularly following storms. At Dinas Dintley, the community excavation was a great success with some exciting discoveries. Outside the hill fort, we uncovered evidence of Neolithic activity, medieval and post-medieval settlement, and within the hill fort uncovered an exceptionally well-preserved and large stone roundhouse, 13 metres in diameter, along with a small Iron Age hammerhead, the first of its kind found in Wales. Such a wealth of archaeology showcases why it is so important to undertake research and investigation at threatened sites. Further excavation is now planned, working in partnership with the National Trust, Cadw, and the Gwynedd Archaeological Trust. Both excavations also revealed a story of sand, many tons of it filling the inner ditch and also covering the archaeology in the trenches, all evidence of past storminess, and an area which CHERISH partner Aberystwyth University is undertaking important work. Across Wales, we have records dating back to the 12th century that reference weather events, but prior to this, the archaeology and often the deposits covering it tell us the weather story, as is the case at Dinas Dintley. Here, the Earth Sciences team have recovered samples from the sand deposits within the ditch section and trenches for luminescence dating, which will provide us with a date for when the sand was deposited and last saw light. This work will complement other work the team have undertaken in the region and provides an insight into past weather, into the nature of extremes faced by past communities, but also providing a long-term context to current and future climate risks. Over the next few years, our work will continue at Dinas Dintley, with the results drawn together for publication, information provided to the National Trust and Cadw to assist the management and future monitoring of the site, and a set of new interpretation products such as reconstruction drawings and animations. Now I'm going to hand you back to Kieran, who will look in more detail at examples of how we assess change at our study sites, based on analysis of our baseline and repeat monitoring data sets.
Thanks, Louise. And what I hope to do over the next pair of slides is to show some of the technique that we're applying that is trying to quantify the change that we're seeing. So going beyond the baseline data to understanding change. And one of the sites which we've looked at and we've been fortunate enough, in inverted commas, to record change over the duration of the project is Dunbeg Fort in County Kerry, where over the course of 1 year, surveyed by the Discovery Programme, we see a loss of some of the wall enclosure of this fort. And, looking at it visually and comparing the orthophotos, we're able to say that there's about 3,000 meters cubed. We're able to look at where it is. We're able to tie it into, in this case, a specific high magnitude rainfall event that occurred. But we also want to see the ways that we can actually start to quantitatively analysis the change that's going on. And so one of our sites in County Wexford, this is Kilmichael Point again, in Kilpatrick Beach. And while we surveyed, the CHERISH project surveyed in 2019, the landowner has actually commissioned a survey in 2016. And so the images that are showing here is a DEM of difference. So that's the 2019 elevation compared to the 2016 one. And in the larger images, it is color coded. So red shows a loss of elevation, i.e. erosion, and blue is a gain in elevation, i.e. perhaps deposition or vegetation growth in some areas. And so focusing in the south of this area, that there's one part where we're able to see focused change, and we're able to put numbers on it. And so overall in the black polygon that's been identified, we're looking at about 4,500 meter cubes of material transported out of that area in the 3-year window. We've also tried other techniques, and so rather than looking at the DEMs that we've produced and comparing those, can we go back a step? And we've been using Cloud Compare software to compare the point clouds. And there's an area we've been looking at since 2017 in Rosslare, and we're seeing a lot of change happening there. And the three images at the bottom, the D, E, and F, show the difference between successive years. D is 2017 to 2018, E is 2018 to 2019, and then F is for all 3 years combined. Again, red is erosion and blue is deposition. And again, what we're seeing here is that perhaps erosion is focused in certain areas, that it moves. It can be quite episodic, changing from year to year. And again, we can actually put numbers on that. So in this area here, we're looking about 850 meters cubed between 2017 and 2018, and about 700 meters cubed from 2018 to 2019. And so we'll be using this technique applied in other areas. One of which is applying it to looking at shipwrecks and the changes that are happening there. And using successive surveys, on the left is the Manchester Merchant from 2009 and 2019 when the CHERISH survey went in there. And the image beneath it is that change in elevation. Color coded, we're able to see that the areas of green around the bow and stern. You've got about a meter change in elevation in the 10 years between 2009 when Infomar surveyed to 2019 when the CHERISH project did that. And this idea of looking at the change, we also want to apply to the City of London, which is that series of images on the right, where we now have 3 time series surveys, and we actually hope to acquire data from both of these wrecks again in 2021, which will give us another DEM to compare difference. Continuing from the baseline surveys to then looking at change and focusing on change, and then from that understanding it to inform management decisions at the sites that we're looking at. And with that, I'll pass back to Louise.
Thanks, Kieran. This slide sums up what we hope will be the main outputs and legacy of CHERISH when the project comes to an end in 2023. There will be a wealth of new survey data available to share and reuse. We will have created accurate baseline data sets for over 30 sites which can be used going forward to monitor and analyse change. Through our work, we've increased knowledge on a selection of heritage sites at risk. Stakeholders and landowners will have been provided with management data and new interpretation data and products. We will have shared our good practice guidance for recording in the coastal zone based on our toolkit approach as a guide to others. The first part of this in relation to UAV surveys due to be launched this spring. We will have raised awareness of the impacts of climate change on heritage to coastal communities, and we will have provided a long-term context and an increased awareness of the dynamic nature of our coast. And finally, I want to draw your attention to the CHERISH free online conference to be held on Wednesday the 12th of May. This will showcase a wide range of speakers from across the globe covering a range of topics around the theme of understanding and managing coastal heritage under threat. Registration has just opened and you'll be able to find out more information from the CHERISH website and our social media accounts. Here's all our relevant contact information, website and social media accounts, so please do follow us. We also produce a newsletter every 6 months. The latest version is due out any day and all versions are available to download from our webpage in Welsh, English and Irish. Diolch, thank you.